Yes, it didn't announce anything, but I'm assuming. Hi, everyone. So now, welcome to our second community meeting. As I can see from the participants, today we have Intuit, NVIDIA, Google, BlackRock, Adobe. Any other company I missed? Okay. So today's agenda is actually to go over our new project, which is Argo Events. We had been discussing the use cases and requirements for that project, and actually the BlackRock guys reached out saying that they have already built the event framework around Argo, and a couple of us from the community looked at it, and it looked awesome, and so we asked them if they would like to contribute, and they did. So we now have a Argo Events repo with code, which you can look at, and yay, and then we will let actually Matt and Vaibhav present how Argo Events looks like and what are the features, and then we will open it up for questions. Anything else? Otherwise, Matt and Vaibhav, you can start sharing.
Okay, awesome. Well, first of all, I'd like to say thank you because we're very excited to become a corporate contributor to Argo, and we're very excited because we've already seen like the stars and the forks on the repo, the past couple hours. So it's very exciting from our side. So I'm actually going to share my screen and I'll jump into a short presentation before we go into a demo. Let's see. Just share my screen. Okay. Let me know if you guys can.
Yes,
we can see it.
Okay, can you see this? Is this too big or is this good size?
That's fine.
That's fine.
Okay. All right. So yeah, I mean, my name is Matthew McCauley, and I've been working with Vaibhav Page at BlackRock on this project that we called Access, which I guess when we donated it, you guys, it'll be commonly known as Argo Events. So I'll give you guys a little bit background of kind of like where we were in the beginning of kind of developing this project, and some of the Intuit folks may be familiar with this. So this is kind of like a high-level diagram of what our project kind of envisioned and what we were trying to design essentially. So we kind of like we're given the task of designing a scheduler for a platform level scheduler for like batch job processing, and so we were researching a bunch of different platforms for workflow execution, and we kind of landed on Argo, and we saw like, oh, this is a really good platform for a number of different reasons. I don't really have to repeat them. You guys already know that. So we also noted there's a couple things that we're missing, and one of the things that we're missing was an event framework. So this is where we kind of came up with the idea for Access. And so you can take this diagram. Basically, what we were trying to build was something that could, work together with Argo. And then we were attempting to build like a scheduler API on top of it to, interface with users' ability to run various workflows, cross-team workflows. So this is kind of like the project and where it is right now. You see S3, we're kind of using S3 as a store for a store for our workflows, our workflow definition and YAML files right now. But this is very subject to change as the project evolves. So that's a basic background. And quickly, like how we're using Argo at BlackRock, and why. Like I said, like it's Kubernetes native. We can do sequential parallel jobs. You guys already know this. And the workflows as DAGs was a really big a positive feature for us, and also like a really strong community. We saw a really strong community around the project, and particularly on our side, the use cases we wanted to perform, batch processing jobs, ETL pipelines. If you're not, I guess if you're on audio, can you mute your microphone? Okay. Yeah, so the use cases, we were looking at batch processing, ETL pipelines, FTP like Polar jobs, and we also wanted to use it for our data science platform. Yeah, so that's kind of what we wanted to do with Argo. And then to tack onto that, our project called Axis, and our kind of design was to make it reactive, make it be able to respond to events. So we designed it in the same kind of way that Argo designed their workflows. We have a sensor custom resource. We can define dependencies and actions, and we kind of like run them in a efficient manner in these pods. And then kind of why we did it, because we looked at a bunch of alternative solutions. Like we could leverage like functions as a service platforms, like, you know, Nucleo and Kubeless. And we kind of thought that they didn't really give events the first class, you know, citizenship that they really deserved. We also wanted to make this Kubernetes native, just like Argo, and we wanted to be able to handle like complex dependencies. So, which we'll show in the demo later. What I mean here is like multiple, not just a single event, maybe multiple events with constraints and various like other settings. And then also being able to repeat like signals and repeat sensors. This was a pretty attractive option for us, especially because we have like a daily or cyclical batch processing. We didn't want to keep you going in and creating another function that would execute, you know, some Argo workflow. So now I guess I'm going to stop sharing, and I'll hand it over to Vaibhav to give a demo. So we'll be covering a bunch of different sensors here. So I'm going to stop sharing. Vaibhav, you can take it.
Thanks, Matt. Can you guys see my screen?
Yeah.
Okay, perfect. So yeah, what I have here is a bunch of like terminals. I'll walk you through what each one of these are doing. So over here in the first section, we have the pods that are running in our Kubernetes cluster. So we have Minio, we have Nax, then we have the actual Argo workflow controller, the sensor controller for our sensor, and there is a tiller pod running for Helm charts. Over here, I'm going to watch the sensors. Here, I'm going to watch the logs. Here, I'll show you how we actually wrote the sensor and what the sensor is. Basically, here we are watching the pods, and here we are watching the jobs. So, yeah, let me just show you how a sensor looks. So over here, you see this is a calendar sensor where the signal is basically a time. We are waiting for a particular interval to happen. Here we are waiting for 30 seconds, and once this time signal is resolved, we are going to trigger this particular.
Yeah, sorry, go ahead.
Yeah, we are going to trigger this workflow, and just show you. Over here, this is the Minio S3 storage, and we store all our workflows here. So it's going to go to this particular S3 store. It's going to fetch that workflow, and it's going to trigger. So let me just go ahead and create one workflow. And in the other terminals, you will see that what's happening with the system and stuff. So, okay, so over here you see the calendar sensor was created. There is a calendar example sensor job, so it's like container creating. Over here you see this is a sensor control logs. Basically, you see that calendar sensor has been marked as init. The phase has been marked as now active. Sensor update is successful. We are basically waiting for 30 seconds, and once 30 seconds are passed, we are going to mark this job as successful and then trigger Argo workflow. The Argo workflow we are triggering, basically, it's a simple hello world workflow. It's not doing nothing fancy. So you just have to wait for, yeah, there we go. So it successfully completed the job. It fired the trigger. Over here you can see the hello world workflow has been created. And yeah. So this is a basic sensor with the calendar as a, basic, time as a signal. The next one that I'm going to show you guys is S3 sensor. Sure.
Quick question. If you don't mind.
Sure.
Does the workflow YAML or the workflow definition, does it always have to be in some S3 bucket? Can it be part of the sensor object itself, the sensor YAML itself?
Well, right now, what we have is we basically need to have an artifact where you can actually store your workflows. So you need to have some kind of store where you can like plug in that store over here. You can mention artifact location. Right now it's S3, but yeah, you can have a database or anything like that.
I think also like we plan to actually include it as like a manifest in the actual definition of a sensor. So you can just execute like kubectl, create commands on it in the pod. That's in the pipeline, and I know like from the interview folks we've discussed this before, but we haven't implemented that yet.
Fair enough.
Yeah.
Sorry, just a question, but yeah, we can always build on this.
Yep.
Yeah, definitely. I'm going to create the next one. The next sensor is basically an S3 sensor where we are waiting for a bucket notification to happen, and then we are going to trigger a workflow. So S3 sensor looks something like this. This is just metadata. Over here you have the signal. Basically, we are using Minio as our S3 storage. Some configuration of Minio, the access key, secret key, and the event that we are waiting for is a put event. So I already configured the bucket notification before demo. So using the Minio client, and again, the workflow that we are going to trigger is basic hello world workflow. So. So over here you see we created the S3 sensor. The S3 sensor job is being created. The sensor controller marked the phase as init, and now we are going to the S3 store, Minio, and I'm going to drop a file .txt because I configured the notification for .txt extensions. So I'm going to upload a .txt file. Yep. You see the sensor completed successfully. Over here, the hello world workflow is being created, the container is being created. That's the basic sensor with S3 as a signal. The next one I'm going to show is webhook signal, where basically you're waiting for, so the webhook sensor basically is it's a simple HTTP server where you configure your endpoint, you configure a port, and it's that particular sensor, that job is backed by a service, and that service is exposed outside the cluster. So anyone can send a request to your cluster, and then basically the sensor will trigger the workflow. So this is how the webhook sensor looks. Over here, you have a port 9. We are running the HTTP server as 9000 port. The endpoint, we are interested in /app, and the HTTP method is post. And again, it's going to trigger a simple hello world workflow. So what we did for the webhook example is we created a webhook in our GitLab. So basically, we are going to, and yes, before that, I'll show you the service.
I think you need to create the sensor first.
Yeah. So, created the sensor. Over here, you see the service got created, and this is the pod. It's being the container is being initialized. Yeah. Perfect. Now it's running. So over here in our GitLab, I created a simple webhook notification, and I'm going to test it. I'm going to send a push event. So that should trigger the workflow. Send push event. Okay, successfully updated the, there we go. Hello world workflow is being executed, and you see the webhook sensor job is being marked as complete. So basically, you can define any endpoint over here. Any HTTP method is supported. You can have any HTTP method. Also, like if you send a wrong, like if you make a wrong request, like if let's say the sensor was like it was listening for a post HTTP method and it sent get, it takes care of that. So yeah, this is a webhook example. Next one I'm going to show is a combination of different signals in one sensor. So it has combination of calendar signal and S3 signal. So you see the first one over here is first signal is time. Again, we are waiting for 30 seconds, and the second signal is S3. The notification that we are interested is input notification. Yeah. Okay, the sensor is being created. You see the job is getting created over here. The logs are updated, and we can go over to the S3 store. We can re-upload the .txt file. So that should take care of the S3 signal. And once this 30 seconds are passed, we should see the actual workflow being executed. So we just have to wait for that time to pass.
This is all RAM, right? This is all.
But over here, you can see this the S3 signal got S3 signal succeeded, the time signal succeeded, and you see we are actually executing the steps workflow, not the hello world workflow. So yeah, these containers are being created until. So yeah, that's what we have for the demo, the example sensors. Do you have any questions?
Oh yeah, I have a couple of questions. So the first one is, so when you mention S3, do you actually mean that it's usually in your implementation it's abstracted away by Minio, so it's easy to switch between S3, GCS, or on-prem Minio?
Yeah.
Okay, cool. So it's
pretty much configurable. Like yeah.
And then my second question was about when you trigger an event based on, let's say, new content added to S3, how does the workflow know the content of the event?
So that's something we are right now working on. So we don't exactly pass the payload of a signal to workflow. We are working that right now. So it's in a pipeline. So once we get that out, you will be able to like pass the payload from the signal to workflow as input. Yeah.
Okay. And you will pass, your plan is to pass the whole payload, or do you plan to have option to only pass, let's say, the...
Yeah, we are also like working on implementing a filter. So also you can have a filter in your signal, and you can define whatever expression you want over there. It will filter the payload and will pass it to the trigger.
Okay, really cool. Thanks.
Yeah.
Weber, if I have two sensors created which kind of react to the same event, will the workflow be executed twice?
Sorry, but do you mean like...
So let's say I create two sensors, both waiting for an S3 put notification.
Mm-hmm.
And both have, let's say, first one has workflow A, the other one, the first one triggers workflow A, and the other one triggers workflow B. And now if I upload abc.txt into the S3 bucket, will both these sensors get triggered and both the workflows get executed?
Right now, we are actually waiting for, listening to the NATS like subject. So it's once that particular message is consumed, only one sensor is going to execute the particular.
Actually, yeah. Both would get executed. Is the simple answer. It does depend on the implementation of the actual signal. If you're using a NATS pub sub, obviously you can have many subscribers, and they would all get and execute the workflow. That's the way it is right now, actually. So you can have two things listening for the same bucket, and they would both.
Yeah, sorry about that. Yeah.
I have a question. What guarantee does this framework provide on, like, after it consumes a a signal, if it fails to, for whatever reason, invoke the workflow, is it lost, or do you only mark that thing as consumed after the workflow is created? Just wondering about the guarantees.
So
So I can talk about that a little bit. So because we're saving the state of everything in the actual the sensors like resource on Kubernetes, I guess like if a pod, for example, went down, or if there was a failure before the like trigger occurred, when the controller picks that sensor back up, it would actually, depending on where it is in the state, it can infer what the next step to do. So if, for example, the trigger failed to execute or something happened in between, it would pick up that sensor, see, okay, the trigger hasn't executed yet, hasn't reached the resolve state yet. Let's go ahead and re-execute that. So I think we can guarantee that once an event happens, and given that it also updates the underlying resource, we can guarantee that the trigger will occur.
Okay, it sounds like it's a at least once semantics. Yeah.
Yes. I guess that also depends on what exactly you want. So if it's like repeated, if it's repeated, then it would be at least once. Yeah, I think it's at most once. I'm not completely sure about that. I think at least once.
I mean, I guess the question will be what happens when you issue the workflow and something fails fundamentally, and
so you mean like
sorry, go ahead.
You mean like issue the workflow, like, so that means like the signal is being consumed and now you're on the the step of like triggering the workflow?
Yeah, but you would detect that let's say if your controller itself dies, you've already recorded that you started the workflow at that point?
No, there's a job in between, right? So the controller triggers the Kubernetes job, and then it's the Kubernetes job's responsibility to make sure that the workflow executes successfully. Is that right?
Okay. And this is unlimited retries on the job, basically?
Yeah, the job is limited to like one completion. So if the job fails like 50 times, it'll keep trying to.
Okay.
Also, another note. So we showed a simple like calendar sensor, and for our purposes, we kind of see a lot of complex like time handling, especially in like business logic and like dates and date logic. So we're working on we kind of support not only just simple intervals, we also support like cron-based expressions. We're also working on handling exclusion dates, so you can specify like basically a list of dates where you don't want something to happen. Part of this is also in the pipeline to kind of create a cyclical sensors that can kind of repeat themselves after not just one execution, kind of like on a daily cycle or a monthly cycle or some defined time period.
Sorry, I just have one question. I'm not too familiar with NATS, but what is the guarantees on NATS itself? I mean, in terms of publishing PubSub?
So NATS is, I believe, at least
depends
once.
Whether you're streaming or whether, I mean, like the streaming server, like but it is at least once.
Yeah, plain old NATS is at least once, and then I guess if you use the streaming server, you can get at most once. Right, but this all depends on the type of signals. So basically, we support a whole number. So we've just shown you a couple examples for S3, NATS, webhooks, and calendars. We also support like AMQP, like RabbitMQ. Let's see, what else do we?
We also support like the Kubernetes resources. So you can
and Kafka, I believe, right?
And Kafka as well.
Yeah.
Yeah, some of us have been working a little bit on Kafka and these at least once, at most once, and the new kid on the block exactly once. All these semantics get super confusing. So yeah,
Yeah. Vaibhav, if you don't mind, I could show
Yeah.
a local demo of what I've been working on.
Sure. Let me stop the share.
So Vaibhav's demo actually shows what we have running in a development environment here at BlackRock. We've kind of been working on other things on the side, and one of these is to kind of make this a signal be extensible. So you can essentially define your signal source, and all it has to do is kind of implement a interface. So let's see. Did you stop sharing?
Yeah, I did.
You did?
Yep.
Okay. Why do I still see your screen?
Does anybody else see my screen?
No, I just see.
No.
I just see you. I don't see it.
Yeah. Somehow, Matt, at least for you, I don't see your video anymore.
Oh, really? Oh.
Yeah.
no, I do.
Oh, you do?
It comes on and off.
Oh, it comes on and off.
I don't know. My computer's being really slow right now. Give me a second.
We can
Oh, that would probably help.
give. Do we have updates or?
Yeah. Do you have any updates while he's setting up his?
Yeah. Well, the update is that on the workflow side there are no updates. Yeah, we've been really focused on Argo CD at the moment, so Argo workflow has kind of taken a little bit of a backseat. I'm eager to get back on it once we get. I think we have a release of Argo CD in the next week or two, and then I think once that's out, once that's out for internal use here at Intuit, then I can switch back to Argo workflow. What I wanted to know was what would, like, from any feedback here, what would be your top priorities of things that you would like get fixed in the workflows, Argo workflows? Last time we talked, I think there were big ticket features like queuing, priorities, persistence. But I know there's like a laundry list of other features like the tag templates can't reference or can't use like with params or with items. There's things like once we expand a list, like can we supply that? If we do a fan out of a bunch of steps, can we have that list be a parameter that can be used as the next thing? So what I wanted to ask the community is like, what is your kind of top wish list so I can focus my efforts once I have the resources to switch back to Argo workflow?
So for us, one feature that was important, I think that we filed it, is the one in the last one you mentioned. So because we have a task, for instance, in Argo workflows that generates like an array, and for each array, it's great that Argo basically can start all those parallel branches. But then once all the parallel branches are executed, it's not trivial to gather all the results and let's say pick one of them or have all the results, the reference to all the results produced by all the parallel branches processed into a task.
Okay. So this is the aggregation as a parameter feature that was the issue that we discussed over that one bug.
Yeah.
Great. Yeah, I think that one's a pretty important one to do. I think it can be done once I get the resources. So I'll focus energy there. Any others that people are kind of interested in?
I have two wish lists.
Yeah.
One is, can people contribute some cool examples around, say, image processing, machine learning, batch jobs, data transfers,
Bitcoin mining.
Yeah. Yeah.
anything that is very good to show in meetups and demos to get more contributors.
Oh yeah,
and
McCauley can
adoption.
mention.
Yes,
Yesterday we actually had the South Bay
Kubernetes meetup
Kubernetes meetup
and
and
rubric. And yeah, we showed coin flip and diamonds and all, but I really would
Yeah.
want, so we have two interns whom we can try. But if you guys have any cool examples you want to contribute, please. That is one.
yes.
What was the second one? I'll think about it
Okay.
later. Yeah. Oh, the second one is if there are any meetups outside Bay Area, now that BlackRock is in New York, if there's a Kubernetes meetup, if you can sign up and demo end-to-end, that would be awesome.
Yeah, definitely.
Yeah.
Okay, I think your video looks good to me, Matt.
Now.
Yeah,
now we
I
can
think
see.
my computer sorted itself out now. So I'm going to go ahead and reshare my screen. And I'm just going to demo just one simple example here. So it should be quick. Okay, cool. Can you guys see my screen?
Yeah.
All right, cool. So I've kind of been working on this, like I mentioned before, this extensible like plugin based signal interface. So basically the definition of the sensor hasn't really changed. So I'll just show you what exactly that looks like. This is just a simple, straightforward NATS sensor. And actually what this does is it, as an input, it just takes in a simple, it just subscribes to a simple subject. And then all it does is it just sends another message on another subject. So it doesn't actually have anything to do with Argo here, which is I guess fine, but for this trigger can be anything. This is just an example of kind of like what we envisioned for the signal framework. So here, I'll get a watch for the sensors here. Here is the log file for the controller, and I'm watching pods here. And yeah, so I'll go ahead and create this sensor. Okay, so you can see, okay, we see it created. And then kind of the interesting part here is the logs. So I'm using HashiCorp's Go plugin for basically attaching a service, a plugin over RPC. Actually, in this case, it's gRPC, and it simply implements the signaling interface. I guess, I don't know why this stopped. Oh, I gotta do that. Okay, so, and also in this, I'm just going to basically send the message on that subject that I was subscribing to. So here, I'll just send the message. We see almost instantly the executor picked up the NATS message, and it kind of like resolved the signal, finished, and obviously we see from the logs, everything is done here. And the job is complete. So it doesn't really show you too much into kind of the change, but actually on the back end, it's completely different from kind of where we were before. And I actually just opened kind of like a work in progress on this on the Argo events to kind of get people's opinion on if this was actually a direction that would be useful. Because I know certainly for us, we have specific signals sources that are kind of internal to BlackRock, and maybe other companies will have the same. So not having to, change a bunch of code to add that as a source to the Argo Events project seems very useful. So this was kind of my stab at solving that problem right now. So yeah, I guess do you guys have any questions? Or, I mean, I urge you to please check out the Argo Events project if you haven't already. yeah, and check out kind of like the issues and where we're you know, seeing or like guess planning the work.
I have a quick question. Is it easy to switch NAT for one of the cloud pub/sub offerings? Is that a trivial change to do, or is it kind of involved?
Yeah, I mean, I guess like with this plugin based signals, like it would kind of be a trivial thing. All you would need to do would be to create, build a binary that kind of like implemented that that interface, essentially. I don't know how familiar you are with the HashiCorp's Go plugin, but yeah, it would be pretty easy to do.
Okay, and if people have like they want to submit such plugins, would they submit it to the repo? Like, are you open to contributions like that?
Yeah, I'm not exactly sure how that's going to work right now. Yeah, haven't totally figured that out. But people should be able to build their binaries themselves, either through like forking a repo or just like building the binaries and attaching them in a Docker file.
Okay, thanks.
Okay, so the next step is Pascal. I know you wanted to try it, and we wanted to try it too. So people will give it a try and open issues or pull requests.
Or Slack, right?
Or Slack.
Yeah.
Okay.
So to get started, do we need to build it ourselves, or is there published images?
We actually haven't published any images, so yes, for now, you'll have to build it yourselves.
Okay, no problem.
There is I tried some of it yesterday, like the namespace for the image is still Argoproj. So we might want to change that so that we build images that are specific to our namespace on Docker Hub or wherever, so that we can push our own images in our own repo, test it out.
Okay. Yeah, and then we'll need to give you access to the Docker Hub, right? Yeah.
Okay.
Yes, exactly. So.
Okay. We'll work on that.
Okay. So we'll work on the build process. Okay. Anything else on this topic? Otherwise, we don't have any demos in this community meeting. The next one, the next community meeting will focus a little bit on Argo events, because hopefully by next 1 month, people would have tried it out more and would have more feedback. And then we would, if we don't have any other demos, we would like to demo Argo CD and get some feedback because we want to show it to the Kubernetes SIG apps and the broader Kubernetes community. So I know you guys must be using some other CD products. In Intuit, we were using Spinnaker for CD, and now we want to do Kubernetes native deployment. So that's one project we started, and we wanted some feedback. Any other topics you guys want to discuss in the next meeting? Okay, so we will focus it on Argo events and Argo CD and any new roadmap items.
Okay, so next we'll plan for a demo for Argo CD.
Yeah,
okay.
1 month. Okay, all right. That's all we had today. Thank you so much. Thanks to the BlackRock team, and thanks to everybody else. Have a nice day.
Super exciting.
Yeah.
Right.
Thank you, guys.
Thanks, man.
Thanks.
Thanks.
Bye. Bye.
Bye. Bye.
Bye.